Hello my dears. So in this video we are going to discuss about the different types of relay, in which we are going to discuss about directional relay. My dears, listen one thing. As the name indicate, directional relay means the relay operate in particular direction only. The particular direction is in the sense that when the current is in particular direction, suppose this is the relay, my dear, this is the relay. The cross mark indicates a relay. Suppose the current is in this direction, then the relay will not active. Okay, the relay will not active. That means it simply passes, or the relay will be inactive. The relay will be inactive. Inactive means the circuit will not be interrupted. The circuit will not be break. Suppose the current through this relay is reversed in certain condition due to fault, due to any reason. Okay, if the current here is reversed, suppose this is the direction and this is the other direction, what happen? The relay will operate and trip. That type of relay is called a directional relay. Directional relay. That means the relay will operate only in one direction. So I will explain. I will write here, my dears. I will write here directional relay only in particular direction of current. Particular direction of current. The relay will operate only in particular direction of current is called the directional relay, and the reverse will be the non-directional relay. Non-directional relay means either the current is in this direction or this direction, the relay will not operate. The current is in forward direction or the current is in backward direction, the relay will not operate. The relay will not operate in the sense the circuit will not be trip. The circuit will not trip. That is called the, what my dear, non-directional relay. So this is nothing but a schematic diagram which representing, what my dear, two generators are there, that's S1 and S2. I am going to explain what is a directional relay with the help of this diagram. Okay. So here S1 and S2 are two generators, because we know that in our power system we are not depending upon a single source of energy, right? If our side is faulty, then we have to feed it from energy from the other side, so that we will get the reliability of supply, right? We will get the reliability of supply. So there are two generators. So suddenly this is nothing but the load side, or here we are living. Our home is the load. So what happened means, towards the load the current is flowing all the time. All the time what happened? Towards the load the current will be flowing. That means the current will be flowing like this, flowing like this, flowing like this, flowing here. The current will be flowing like this, flowing like this, flowing like here. The current will be flowing like this, flowing like this, flowing like this, here. So the arrow is simply indicates the direction of the current. So suddenly a fault occur here. Let be F1. Suddenly a fault occur here. What is the nature of the fault means? The fault having least impedance than the load always, because fault means, suppose earth fault, this is earth fault, or short circuit fault, anything. Least impedance means, my dear, increased current, decreased voltage. What happened? Suppose this is these are 2 points. Maximum voltage will exist here when there is no conduction. If the conduction will be here, means there will not be any potential difference, so that the voltage suddenly reduced. The voltage suddenly reduced. Simple principle. So suppose a fault occur here means, what happened? The nature of the fault is that all the current will be, or you can mark like this, at fault point all the currents will shifted towards it because it have least impedance path. I will tell you in detail. So what happened, my dear? What I wrote. Normally the load having the least impedance path when the normal operating condition. So the all current will flow here. So when the fault occur, the fault having least impedance path. So what happened? The current always prefer the least impedance path, my dear. The current always prefer the least impedance path, so that the current will start flowing. The current will start flowing towards this F rather than this load. So let's see one by one. So initially, my dear, the direction of the current is in such a manner that what was the direction of the current? Initially, the current come here and current came here actually. Come to load. This was the initial direction of current, or in other words, you can say like this also. This was the initial direction of the current, or you can say like this. This was the initial direction of the current. Okay. Is it clear? So what happened when load happens in F1? F1 means what happened, my dear? The current will be like this, and it will come here. This current will be come here. Same time. This current will come here. That means this current will come here. Array, when it reaches here, it having two paths. One is here and one is there. But these having least impedance, it senses the current will always follow the least impedance path. When it reach here, that current will reach, that means from here to here, it reach here, it feel two impedances, and it got very happy. The current will be very happy because this is highly impedance than this faulty region, because when it is fault into earth means earth having nearly zero resistance or 3 to 4 ohm resistance maximum. So this current will prefer which path? Is it go here? No. It will come like this, and it will come like this, and it will be left. So I'm representing the faulty current now. Okay, it will come here, it will come here, it will come here, it will come here. Just one current I am only focusing. See, the nature of the current here. Initially, the relay number 4. Focus relay number 4, my dear. Initially, the current was in this direction. The relay won't operate. The relay didn't operate. Simply it passes the current to the load. What happened when the current direction is reversed now? Initially, this was the current direction, this blue line. Now this is the current direction. So what happened? Through this relay, the current reversed, my dear. Through this relay, the current reversed. So I can say that. So now it is a faulty condition. So the relay should operate, right? Whenever there is a fault, the relay should operate. So what happened? This relay will have to operate so that the relay 4 should be directional relay. But see the relay number 1 and relay number 3, wherever there is a fault, just a point after the generator, the current always will be flowing like this. There will not be any change of current there because the current is always flowing like this. So we can say that the 1 and 3 will be probably non-directional relays. That means we can use non-directional relay there because directional relays are costlier than non-directional relay. Why we have to add an extra cost to the power system? So we normally prefer this is the thumb rule actually. Always the generator, that means the relay near to the generator, will be always non-directional, because that region, the generator region, it prone to least fault always, because the generator protection is the pakka protection among all the power system. I mean all equipments in the power system. The relay, I mean the generator side will be pakka protected. It will not fault easily. That is that manner in which it fabricated, or that manner in which it protected. So always we can use non-directional relays. That means it can send current through this, or it can send current. That means suppose the generator is now not operating condition, means at that time also the current will be flowing in opposite direction. That also the relay should operate. But that condition is very rare. That means the S1 is fault, means it is very rare condition. So at that condition, so unless that S1 is not faulty, we can simply use non-directional here. We don't want to add extra cost. But compared to the load side, my dear, when we are treating the load side regions, always prefer directional relay. Load side relay is always directional, source side relay is always non-directional. That is the thumb rule you can use. That is the thumb rule you can use. Okay, and one more thing I will use. Suppose the load is a synchronous machine, you imagine. Then also you can, now suppose the load is simply resistive load, means the relay number 7 you can use also a non-directional. You can use like that. This will be non-directional. Suppose the load is a synchronous machine, synchronous motor. Imagine synchronous motor. Suppose this is a synchronous motor. Okay, this is a synchronous motor. If any problem occurs in the system, what happen means the synchronous motor supply it doesn't get enough supply, means what happen, the synchronous motor will supply. That means if power factor is changing, the synchronous motor will act as a synchronous generator. Okay, so that the synchronous motor will supply power to the system. That is not tolerable, right? That is not, unless it is a power factor correction. Otherwise it is not tolerable. So what happened, normally we are using near to the load as a non-directional relay, but special conditions, if such special conditions are there, we can use directional relay. So in short, source side are always prefer non-directional, load side always prefer directional relay. So the directional relay is nothing but it is an extra costly relay than the non-directional. It senses the current in only one direction. The other direction it will be inactive. So that is called directional relay. Okay.